So I have a name, David, and email, and then I could say link rel add as friend. Some link, okay? And I could say okay, let's say, let's use actual examples. Add as friend is a bit hard, but actually, better idea. Link rel photo. Okay. Now, this is getting a person. So I could say get slash or something like that. Now I say get people or get people, dzuelke updates 1, 2, 3, 4, 5. So the postings, the comments for a wall post I made. You guys know Facebook? I can send status update and people can comment. Okay? You know what I mean, roughly?
Well,
it should be
unpopular here, but
okay, but it should be this should be relatively clear. So you could say comment. So now I get this to get all comments on a posting, okay? On update 1, 2, 3, 4, 5, this is all the comments I get. And now I write an iPhone application with a Facebook client, and I can push a couple of buttons. So I can say, okay, I see a posting, I click comment, and I see a list, okay? And theoretically, what I could do now as a developer of this application, I could say whenever any type of response object I get contains a link rel profile, I will show a little button that a user can press to go to the profile of that person. But right now it's not there. But if I write my app in such a way that there's code and it always looks for link rel profile, if there is a link rel profile, it shows a button. And then I don't have to do any updates. The server, all of a sudden, starts sending this.
クライアントをそのリンクレルプロファイルっていうのは入ってればプロファイルに持っていくっていう風に作ってさえおけばコメント一覧っていうところのサーバーが返すところにリンクレルプロファイルを足すだけでそれぞれのコメントからそのコメントした人のプロファイルに飛ばすことがクライアントの方の動作を一切書き換えることにできます。
And all of a sudden the client will start displaying this. All of a sudden button, and I can click and I can view Joe's profile. That is the idea behind REST. You can add features, and since the client only needs to know the relation, like profile of the feature, he can maybe handle it. Okay, only a few slides left. I will finish on time, I think. So, why is this so good? First of all, because it scales. Not just in terms of performance, but you can extend it all the time. You can add new features. And, you know, Fielding, in his dissertation, he did not write a new idea. What he was is, he wrote down the architecture of the web as it existed back then, and that was 1995 or something. It's the World Wide Web is exactly this. This was always the plan. It only took us 20 years or so to understand it. Because you can seamlessly add operations into your services. And also, the cool feature is that when you have such an interface that follows principles like every URL is just a resource, it doesn't have operations. You use verbs for operations. All of a sudden, and if you use all these headers properly, all of a sudden you can use all these HTTP features. You simply start, well, content negotiation, you saw that already. I say accept XML, I get XML. I say accept JSON, I get JSON. And then you can say, oh, redirect. All of a sudden, the client gets 201 created responses instead of 200 OK, and he just follows the link. You could say, oh, authentication, no problem. You just use HTTP built-in authentication. You could say transport layer security, no problem. Switch your API to HTTPS, and it's a secure tunnel. You could say caching. Oh, I have high load. Twitter has extremely high load on their API. What they do is they just use a squid or varnish, and they put it in front of their service, and someone says, give me all statuses for dzuelke. It never asks an application. It's served right from the cache for a few seconds at least. And that is possible because they have a pure HTTP interface. Load balancing, same story. You can easily load balance this because you never have states in a REST interface. You don't have sessions, so you always need to re-authenticate. With every request, you need to send an API key, for instance, in a header. Ideally, an authorized header. Yeah, never have state. And then you can scale it. If you don't have sessions in your API, then you can say load balance, cache, everything. Everything is possible. Good. Now, we're on time, right? Still, right? 15 minutes left? It's 46. Is that fine?
Yes.
Good. Twitter's API, you know this. At least some of you. So, ever seen this?
Twitter API.
So, why does it have show? How about just this? Why is it? They have api.twitter.com for load handling, so it goes to different machines. But in theory, a load balancer could look at the accept header and say, I send API requests to different servers. This is the API version 1. I will show that later. There is a better way to do this. Because, you know, if I have one here, one status is some ID, and two status is some ID, are different resources all of a sudden. Caches handle them as different resources. Expiry information. Like this, it's one, but you can still do versioning. I will show how. But so this would be a clean URL. So I have statuses 1, 2, 3, 4, 5, 6, 7. Update. You call update. This is another problem. So it would be much better if you don't have that. And the other problem is only the user who sent authentication information. There is no user ID here. What am I updating? I am updating dzuelke if I'm logged in as dzuelke. If I authenticate as Mugeso, I will update as Mugeso. So you cannot have a super user that can update 5 accounts. It's not possible. So why not this? Twitter uses ID status. And then I also authenticate, and then it makes sure that dzuelke can update